Wouldn't it be amazing if you had the ability to rewind to a time when the universe was a baby and the first stars lit up the darkness of space by their light? The first stars of the cosmic dawn are the story that James Webb takes us. But what do we see? Scientists now know, since the beginning of our universe has gone from the realm of theories and calculations to tangible reality, that there is no pleasant truth. It's all completely different than what we've long imagined. One of the architects of the space age was the James Webb Telescope named after. As one of the first heads of NASA in the 1960s, James Webb helped bring the Apollo program into the world and along with that, first men on the moon. Naturally, the new technology telescope is more a milestone than a key to secrets of the early universe. Researchers thought Webb would take us on the journey to the beginning of time, at least. From then, it was quite different. First results from Webb are breathtaking and reveal that maybe we don't know as much as we thought about the beginning of time and the cosmic dawn. Picture-taking Webb and traveling back in time to the start of the universe, where they would have been all dark, all quiet, all empty. The era before is what this story is said to be about. Before the time, before the first stars, the first galaxies, the first light, and before the age of time. The period of the cosmic dawn would be dated to around 100 million years after the Big Bang. Researchers have said so far. At this point, or a little later, problems are not apparent as you don't see darkness and a universe early in evolution. You don't see what happened, only that everything is perfect and awe-inspiring. Understanding the fascination of Webb's findings then rents of understanding how astronomers have explored this epoch of the universe and what theoretical and descriptive language it created. So far, all we know other than theoretically about how the cosmos has evolved. And in the early part of the 20th century, two researchers, either Georges Lemaitre or Edwin Hubble, observed the movement of galaxies about 100 years ago. Galaxies were seeing that they were drifting apart. In other words, this was the first to cause the idea to cross Lemaitre's mind that the universe began from a single point and has since been expanding. To calculate backwards the universe, researchers took Hubble's and Lemaitre's observations, the rules of general relativity, and Albert Einstein's calculations about matter, its movements, and all known physical forces observed in the observable universe. So, the details of what happened during and after the Big Bang were fairly well known to the researchers. It was as if we had found cosmic microwave background radiation which seemed to further confirm these ideas. Until recently, nobody had seen these events. Once again, picture yourself, a researcher patiently waiting for the first pictures, telling us what you have spent your entire life calculating and imagining. The images show you a completely different cosmos, but it's still Bhutas. How would you react? You can be disappointed and shocked, or relieved and excited, and let yourself explore whatever is really there. Right now, the conservative branches of science are having much difficulty with the latter. Other young and open generations of researchers, however, see this dawn of truth as an opportunity to finally understand a lot more about the universe. There were no first stars as we thought there were. Scientists are now searching for the first stars and finding stars entirely different than they thought of for decades. Finding the first stars is extremely difficult. The light they throw is very faint, and the expanding universe has something to do with the small amount of light that it is, turning it deeply red. That's where the James Webb Space Telescope gets its ingenuity. With sensors so fine they can easily pick up the infrared light from the most distant and oldest objects in the universe. The most powerful and ambitious space telescope ever built is scanning the skies. That shows us galaxies that must have been the first after the Big Bang. These galaxies are so large, so perfectly organized, so full of shining stars that they can't possibly be the galaxies of cosmic dawn. At first, only a few globular clusters would have been about as misshapen globular clusters as could be. The legendary stars of population 3 should have been contained in them. These stars were shining and luminous, but short-lived stars. But Webb reveals galaxies already full of very old stars. This shouldn't be right. Webb can now help us truly understand the early history and evolution of the universe by helping us find the real first stars. First stars observations will replace all theoretical models and simulations. A dispute has flared at the moment. New truths. Those scientists are fighting tooth and nail against. They are desperately seeking explanations and desperately want to cling on to their old theories. So, what if those first stars didn't exist simply to begin with? But what if the universe is a lot or perhaps nothing at all? Older, never had a beginning. What if the researchers including Lemaitre and Hubble were all just wrong? What really were the first stars formed like? It occurs I cannot imagine stars always having been there. Stars in an infinite universe. We humans, however, have gotten used to thinking in dimensions presupposing a beginning and an end, so this becomes difficult for us. Many of the people, however, found the concept of infinity, or things that go beyond mathematics, numbers, or even physics, difficult or even impossible. Of course, even if stars have been there since the beginning, whatever beginning is, there are star-making processes like this. On the one hand, new stars are being made in the cosmos all the time. On the other hand, old ones are dying out. These clouds of gas and dust become stars. The molecules which make up these structures are basically just hydrogen, which is why we call them molecular clouds. Claudine Norris told me that the force generated by condensations in these clouds eventually forms such massive forces that a star can be born in the center. A region in such a cloud becomes critical when it reaches a critical density, and then collapses under its own gravity. The result is to heat and press the core of the cloud to create conditions hot and dense enough for nuclear fusion to occur. With this, we see the star light. Stars themselves are still hidden behind dense clouds of dust, and it is hard to break through their light. And then, the cloud clears, and planets can form out of what's left. In some cases, the forces are strong enough to form a second star, and a binary system is formed. We know today that there are millions and billions of galaxies in this universe, and each galaxy contains millions and billions of stars. The number of stars in this incredible galaxy tells us how ubiquitous and essential star formation is to the universe. This means that stars are all different ages according to their mass. These findings are certain, since they are from actual observation. But the theories regarding how the universe began and the first stars in the cosmos didn't make a consensus. Only since the launch of the James Webb Telescope have we been able to observe this epoch with our own eyes.